Welcome to Let's Build It. My name's Betsy Edwards, and today I finished my cable railing project to create a safe play area for my pups Bella and Milo. In this video, I will show you how to install a new cable railing on a deck and a stepped retaining wall. I'll also discuss how to build and install the wood support posts, how to bevel and install the top rails, and tips on how to make the installation of the cable balusters easier and more efficient. My first step was planning and ordering the materials needed for the lumber and the cable installation. I purchased 4x4 pressure-treated lumber to build my posts. If you choose pressure-treated lumber, you will need to stack it and let it dry for about a week to obtain a 19% moisture content level, which is required by building code to ensure structural integrity. When making the support posts, to keep things looking consistent, I followed the post design of my existing deck. I notched out a 2" by 9" section from the bottom of the post to allow for a 9" long tail for securing the post to the rim joist and a 2" bearing on top of the deck. You do need to make sure that you secure the post to a rim joist that is at least 2x material and that the support tail is the same depth as the rim joist. So here's a post. A new post that I've dry fitted in. It's not attached yet. And now I'm checking for plumbness flush against the rim board. So you can see in this situation, it's not plumb. And in order to make it plumb, I'm going to have to adjust that tail about 1/4 inch. So let me show you how I'm going to do that. Holding your level flush against the post, tilt the post until plumb, and then measure the distance between the rim joist and the support tail. Sometimes your rim joist can be warped one way or the other, so be conscious of which direction you are adjusting the plumbness for. Then transfer the measurement to the post. Now draw your cut line and remove the excess with the jigsaw. You will want the tail to fit flush against the rim joist, so an oscillating tool works great to clean up any ridges or bumps. There you have it. When fastening the posts, I use 2 1/2" galvanized hex bolts per post. This will provide a stronger hold over time because the bolts go all the way through the structural lumber and are secured on the back side with a washer and a nut. I used a 1/2" auger bit to drill fastener holes all the way through the post, tail, and the structural lumber. And finally, don't forget to do one more plumb check. When making my top rails, I decided to bevel with a 6° slope to allow the water to run off more easily. I did this so I can minimize water sitting on the top of the rail and potentially causing damage over time. I started by setting the height of the blade on my table saw to the middle of a 2x6 board, then set the bevel to 6 degrees and then the rip guide to 1 1/8 inches. Next, I ran the board through, then flipped it over and ran it through the other side to create the center pitch. Not all railings will be a straightaway, so when there's a turn in the railing, creating that perfect angle can be a little tricky. To get a close to perfect join, place a scrap piece of board along the straight edge side and then trace the angle over the joining board. Then bring it over to your miter saw and align the blade with the line you marked and proceed to cut the angle. I secured the top rails to the post with 3" exterior decking screws, countersinking the screws about 1/4 inch and finished with dowels to conceal the screws. For the stepped up rails, I used a different approach. The far end was secured to the top of the post just like I did on the deck. On the step up, I butted the end into the side of the post. To achieve this, I needed to notch out a section of the post to give the rail vertical support. I leveled the rail and placed a mark where the bottom of the rail meets the post. Then I marked 2 straight cut lines for my guide. And finally, I used a circular saw to notch out the groove.
Next, I had to create a tongue on the end of the rail so it would attach snugly to the groove on the post. To give the post a little style, I left a 1 inch by 3 inch edge as trim, and to ensure a snug tongue and groove join, I cut the tongue to a thickness of 3/4 of an inch. I then positioned the rail, pre-drilled with a 3/16 drill bit, and fastened with 2 5-inch Timberlock structural screws. Now that I have all the posts and rails built, I can proceed with installing the cable system. There are many choices for your hardware supplier. I used Mazada in my project, and you can find the links to the products that I used in the description below. One of my primary goals when installing the cable runs was to ensure that each run was level across the posts. To achieve this, I created a drill template out of a 2x4 with drill holes 3 inches apart and centered. I spaced the cable runs 3 inches apart to ensure the railing meets code in the event there is any deflection in the cable. National Building Code requires no more than a 4-inch spherical space between cables, so spacing the cables 3 inches will account for any deflection that may occur over time.
I am a big fan of dry fitting everything before I actually secure and cut. Where I started, the wire is still on the spool, and I'll show you how I cut into that. I'm going to install the terminal end first, and then I'll go back and install the tensioning end.
With the cable run through the end post, slip on the washer and then the terminal onto the cable. Then use the hydraulic crimper to secure the cable to the fastener. I placed 2 crimps in each fastener to ensure it will hold over time. Then go ahead and hammer the terminal into the post. Next, pull the cable taut back through the posts.
Now I'm going to install the tensioner side. I'm going to cut the wire right at the edge of the post. I've already crimped the cable to the tensioner. Put in my washer, my nut.
To tension the cable, hold the one end of the tensioner with the pliers and secure and tighten the nut on the other end until the cable is tensioned. When I finished installing the remaining cable runs, as a final step, I installed the end caps on each bolt. The end cap is more of a safety measure to prevent injury from the protruding bolts. I had to pull out my handy Dremel ultra saw with the metal blade to cut down the bolts to size so the end cap would fit snug. I'm very excited with how it turned out, and I think Milo approves too. Thank you for watching. I hope you found this video useful and will subscribe to my channel for more building projects and tips. For anyone who wants to watch the hydraulic crimper tutorial, wow, that was a mouthful, I did add it to the end of this video.
Okay, on the crimping tool, I have a dial which turns the hydraulic pressure on and off. To crimp, you turn the pressure on, you have your 1/4 inch dies in place, and a trick I've learned, instead of trying to hold the wire, the cable to the fastener and crimp, holding it all together, just go ahead and put the fastener in the tool and get it into position. So you pump it just enough to where it's holding it in place. You use your fingers as a guide to where you want the crimp to be. Then you put the wire in, and again push it all the way flush to the end, and then you would crimp like 1, 2, 3 until it's catching. Then you pump it a couple more times until you cannot pump it anymore, and then it's fully crimped. And then you turn the dial off to release the pressure. So then you can see it's crimped in one place.